All right, ladies and gentlemen, hopefully this will be the end of these, and we can do successfully on your tests. So let's go back. We're going to look at another molarity problem. Really nice and easy one. This time you're going to just want to know how many moles, and they give you a solution volume, so you just have to multiply by the molarity. So this is a very nice, simple one. So we'll do that. We will take the 50 milliliters. The only kicker on it is you have to remember that on the 50, you do have to change that to liters. So you're going to have to divide by 1,000 milliliters to change it to liters, and then we're going to multiply that by the molarity, which is 12 moles per liter. Remember, the M means moles per liter. So liters cancel, milliliters cancel, and 50 divided by 1,000 times 12 is 0.6. Now we can write that answer, in this case 2 sig figs, it's 0.60 moles. And of course our answers there work usually most of the time. This time let's know how many grams of solute are in 400 milliliters of a 2 molar solution of copper 2 hydroxide. Copper 2 hydroxide. There it is. I'm going to go ahead and use my little calculator for this. And you can see that it's 97.6 grams per mole. We'll keep that over here for us. And we will take the 400. So this time we are going to start. Let's look at it. We want to get to the grams. We'll get to mass, and they give us a solution volume. So we're going to have to come from the solution volume, divide by the molarity, multiply by the molarity to get to moles. To get this way, we're going to multiply by moles per liter, so that would be multiply by the molarity. Then we want to get to mass, then we're going to have to multiply by the molar mass. So we're going to do 2 multiplications this time, which is kind of rare, but in this case it's going to work for us. So we will go up there and take our 400 milliliters. And remember, the first thing you're going to do to that is 400 milliliters. We're going to divide by 1,000 milliliters in a liter. And we'll multiply by the molarity, which is 2 moles per liter. So notice my liters cancel. Then we'll multiply by that molar mass, which was, remember it over here, 97.6 grams per mole. Moles cancel. And we should get 78.4 if we do that. So I got 78.1 actually on that, so a little bit different than their answer, so 78.1. But we'll live with it. All right, so we'll go down to number 20. And on number 20, we go back to our document. We'll scroll down to that. This one's going to be just like this one. Thing is, we need to know what iron perchlorate is. So that's our biggest issue. We haven't used perchlorate very often in terms of our ions, but it's ClO4, and it's a -1, and this is a +3. So we're going to be FeClO4 3 times. Save a little time, we'll just type that in. And that's a nice hefty 354.2 grams per mole. So we're going to do that same methodology. 125 milliliters, this time 4 sig figs. 1 liter, over 1,000 milliliters, and then we are 0.5 molar this time, so 0.5 moles per liter, and then we're going to take that times our lovely 354.2 grams per mole, And liters cancel, moles cancel. And we're going to hopefully get somewhere around 22.06. 22.1 I got, so very good. 22 point. I got a little hair more than that. I think they're doing a little more rounding, the source I got these problems from. So we'll call it 22.1. And actually it's only 1 sig fig, so technically 20 would be the correct answer on this one, 20 grams. What volume of a 6 molar solution would be needed to make 100 milliliters of a 2 molar solution? So this is going to be our good old dilution problem. So M1V1 equals M2V2. In this case, this is more concentrated than this. So this is our dilute solution, and this is our concentrated solution. So in this case, we're going to use our 100 2 molar here times 100 milliliters, and that's, we're going to assume that's 3 sig figs there, even though it's written as 1. And over here we're going to put in 6 molar, and we're going to call that V1. So 2.0 molar times 100 milliliters divided by 6 molar. This is going to cancel. A third of 100 is going to be 33.3 milliliters of the concentrated. Now this was 2 sig figs, 1 sig fig, so technically 30 milliliters. But I'd never make this way. I would do the 33.3. But our correct answer based on that is the 33.3. Alright, so everything's a little modification of these that we go into these molarity problems at the end. And we'll come back up and pick up those last problems. So we have a couple more to go here. How many grams of ammonium carbonate are needed to make 12.5? Whoops, lost our... I don't know what's going on here with our device, but we'll try to clear that up and go with that. So back to the problem. Looks like we lost it. And let's see, there we go. So how many grams of ammonium carbonate are needed to make 12.5 liters of a 0.5 molar solution? How many grams of ammonium carbonate? So ammonium carbonate is NH4,2CO3. So I have 2 nitrogens, 8 hydrogens, and a carbon, and 3 oxygens. So 14.0, that's going to be a 28. 8 times 1 is going to be 8. 12 times 1 is going to be 12. And 3 times 16 is going to be 48. It goes 0, 24, 26, 6, 8, 96 grams per mole. So on our mole map this time, grams, we're going to multiply the molarity times the volume, 12.5 liters times 0.5 moles per liter, multiplied by the molar mass, 96 grams per mole. So liters, liters, moles, moles, we're going to get grams. So 12.5 times 5.5 times 96 is right on the nose, 600 grams. 3 sig figs, 1 sig fig, so 600 looks good. What volume of 14.8 molar of nitric acid solution would be needed to make 250 milliliters of a 0.5 molar solution? So here we go again with our concentrated. M1 V1 equals M2 0.5 molar times V2, 250 milliliters. So, rearranging, V1 is 0.5 molar times 250 milliliters over 14.8 molar, and that comes out to a lousy 8.45 milliliters. So it doesn't take very much of this concentrated to make this fairly dilute solution, we're making a quarter mole of it. What would be the new molarity for a solution made by diluting 25 milliliters of 6 molar KCl to a final volume of 500 milliliters? So 25 milliliters, that's going to be V1 times M1, which is 6 molar, equals, wants to know the new molarity. So V2 is 500 milliliters. And this is going to be M2. Sig figs in this are atrocious because here's 1, here's 2, here's 1. So we're really looking at 1 sig fig here. So this side's going to be 6 times 25 is about 150, which is milliliter molar. And this side is 500 milliliter times M2. Divide both sides by 500, and we get 0.3 molar. STP conditions. We said the STP conditions are 0 degrees Celsius and 1 atmosphere of pressure, which is also known as 760 millimeters of mercury. What does STP mean? Standard temperature and pressure. What's the volume of any gas at STP? 22.4 liters per 1 mole of any gas. Mr. Avogadro's famous statement. And that leads us to our last question. Why is the mole used in chemistry? And real simply, the mole is a way to count particles. And the nice thing is, if you take 6.02 times 10 to the 23rd particles of anything, which is 1 mole, it will have a mass equal to its atomic mass in grams off of the periodic table. Equals 1 mole of anything is a mole of those particles equals the atomic mass in grams of that substance. So 6.02 times 10 to the 23rd atoms of carbon is a mole of carbon, is 12.0 grams of carbon. And that rounds us out for the study guide. See you for the test, and remember, stop in on Power Hour. Stop in anytime if you got any issues with it. Have a good day.